In this video, I will show you how to create an animation using Blender. From the rigging, animating, creating the scene, exporting, and post-processing in DaVinci Resolve, you'll understand the entire workflow to create beautiful animations to put on your social media and your portfolio. And for those who doesn't have a model, I will let this file here on my Gumroad for free, so you can follow the tutorial with it. The link is in the description. And as a reminder, this is not the only way to do things. There are probably many ways to do this kind of stuff. This is the way I do it, and I enjoy the process, so I hope that you do as well. Without further ado, let's jump right into it. I hope that you learned something from me today. First thing that you need to make sure is that the scale of your model is set to 1. After your scale is applied, press Shift-A, go to Armature and Single Bone. You can see that the bone is hidden behind the geometry. With your armature selected, go into Object, Viewport Display, and mark in front. Now we will be able to see our armature in front of our model. Go into the Edit mode by pressing Tab and position where your root bone is going to be. So this bone will be for the head and overall things that will not move. Now we're going to start adding the bones for the legs. I'm going to start with the left front leg. Now select the tail of this bone, press E and Z to extrude down. Now I will select this bone and move roughly where my axle will be. Now, if you're following the tutorial with a model that is not the same one that I'm using, you will need to make sure that when rigging mechs and other kind of robots, the movements of the joints must make sense, just like in our arms or legs. First, we have this Z-axis bone here that will be responsible for rotating this part here. Now, we need to make the one that will rotate around this axis. I will go to the side view by pressing numpad 3 and extrude a bone and locking it to the y-axis. I'm placing the center of these bones roughly where the center of rotation will be. Otherwise, the rotation will be lopsided. Depending on what you are doing, you do not need to be so precise about this. Again, I'm going to extrude another bone now in the X direction. And remember, there is a bunch of ways to do this kind of stuff. This is the way that I did for this project. A lot of people seem to have interested in it, so I'm sharing here with you how I did it. Now for the next part of the leg, I'm going to press X and Y and extrude towards the other joint. So this one will rotate like this. Sorry, this one will rotate here. And there will be another one that will rotate around its y-axis. Now I'm going to place another 2 bones in the z-axis by pressing E and Z. One around here and one around here. And I'm going to place this bone aligned with the wheel axis. The position for our bones are roughly in the place. And now we're going to set up the IK rig. Now select the head of the last bone and extrude it again. This can be in any direction. I like to put it forward. It's just a personal preference. You're going to select this last bone, press Alt and P and clear parent. So this bone is not parented to the other ones. Now going back to object mode and pressing Ctrl Tab, we will enter the pose mode. Select this bone and this by pressing Shift and press Shift Y and add IK to active bone. Now you will see that if I grab this IK controller, which is our last bone here, when I move it, all the other bones will move it with it. One thing that it's very important and you need to keep in mind is the length of the IK chain. To change the setting, we will need to select this bone here, the yellow one, which is the bone that is being controlled by the IK, and change the chain length. This will vary between different projects. You can change the number to test and move the IK bone to see if the movement is right. For me, I need another 3 bones here. I will press Ctrl Z to reset the pose, and 1, 2, 3. So now all the bones are moving. And you can see that if you try to move this bone here, you can only rotate it because it's being controlled by the key controller, which is this bone here. So when you move it, the rest of the leg moves. So now we are going to name our bones, and I like to always show the name of the bones as well. For me, it's easier to keep organized. Go back into object mode by pressing Ctrl Tab, select the armature, go to Data, View Part Display, and Names. Now you will see the names of the bones. We will later use Symmetry to do the other side, but in order to use Symmetry, we need to change our bone names. Here you can change the name manually, or you can change using the batch rename. By pressing the Ctrl F2 keys, I will open the batch rename. I'm going to select the selected objects and change from objects to bones. And here change from find and replace to set name. And I will put front underline L. The front one doesn't really matter for the symmetry, but the L one does. The L stands for left side. Now select the bones that you want to symmetrize. Go into Armature, Symmetrize, and boom, there you go. Now we have our bones in the right side too. And they have the suffix underline R instead of underline L. So I think I actually made a mistake in the order here. I think we need to first symmetrize and then set the IK bones. So select all the bones, go into Armature, and symmetrize. Now again, in the posing mode, by pressing Ctrl Tab, select the last bone here and this one, press Shift I, and to active bone, change the chain length to whichever you need. Mine is 6. And do this for the other side as well. Again, Shift I to active bone and change the chain length. Just verifying if it works. Okay. Now with both sides and the IK setups for the left and the right side, we are going to set up the parenting for the bones. This is the most laborious part, since it's kind of meticulous or tedious. There are 2 ways that you can parent your bones to your meshes. The first one is that you select the meshes that you want the bone to be parented to. Select the armature, go into the posing mode, shift select the bone, and press Ctrl P and bone. Now, if I remove our bone, we will see that the parented objects will move together. I forgot to grab this part here. I will do the same for that again. So I will select the parts that I want to now move with this one here. So I will select this and this. That should be it. Yeah, these ones. So select here, select the armature, Control Tab, select the bone, which is already selected, press Ctrl P and select bone. Then we repeat the process. Now I'm going to select this part and this, press Ctrl Tab, select the bone, Ctrl P, bone, and repeat it again. It's a very laborious task, but for me, it's the way that it works. If there is any better ways, please let me know in the comments. I would love to know. So here I actually made a mistake with the other one. I just need to select this part of the leg, this cylinder here, and then parent it to this smaller bone here, because I will lock the rotation for this bone after, and this is the bone that will rotate this whole thing here. Right here, I realized that I need to extend the IQ bone length because I need that other part to rotate as well. So I'm going to select the IQ bone, go into its constraints, and up by 1 here in the chain length. So it's 7 now. Now you can see that it moves as well. And for the parenting, this and this. And boom. Now we can see that we have a problem. If you extend here, you'll see that our bones are not respecting the mechanical limitations of each type of joints. And for that, we will limit which bone can rotate in which directions. Now going to the armature, post mode, and then go into bone and inverse kinematics. And here we will lock each rotation for the bone. And these rotations are in the coordinate systems of the bones. So the y-axis is the axis alongside the bone from head to tail. If you see here in the using the gimbal and change it from global to local, we will see that the y-axis is in the direction of the bones, and start locking the rotations. This bone here, I just want that it rotate. I just want it rotating in its y-axis. So I'm going to lock the x and z. So we see that we have a better rotation already. This one here too as well. When I lock, just rotate in the y-axis. I think every bone will be the same, just this one that will be different. This one here. This one, we want to make this movement here. This is like the knee. So it doesn't rotate in the y-axis, it will rotate in the x-axis, which is the red one. Much better. And this, in the last one here, will rotate just in the y-axis as well. Now let's see how the movement's going. Some things that are kind of weird here. Oh, I see that what it's the problem. This bone here needs to rotate in more than one axis. This one here needs to rotate in the blue axis, which is the Z one. I unlocked this and let's see how it goes. Much better. Now the leg movement is much more realistic because it respects its joints constraints. Another thing that we need to do in the beginning is that you need to parent the leg bones to the main bone here. So go into the edit mode, select the first left leg bone and the root bone, press Ctrl P and make parent and keep offset, so it will not join the other bone. Do the same for the right side, Ctrl P, keep offset. Now if we go in pose mode and move the root bone, we can see that it sort of moves like an IK2. Now I want to parent all the meshes for the robot to this bone here, to the root one. Now what I want to do is I'm going to parent all the meshes to the armature, specifically the root bone. So I select all the meshes that I want to parent to the root bone, select the armature, Control Tab to enter the pose mode, and Control P and bone. Now if we move the root bone, we will move our entire robot. Now you're going to do the same as you did in the left leg, but for the right leg. So select the objects that you want that bone to be parented, select the armature, Control Tab, select the bone, Shift P, and bone. So it's working. So I will speed up the process, but it's the same thing, just in the other side. Now we're gonna do the constraints, same as before. So select the bone, go into bone, inverse kinematics, and lock the axis that you don't want the rotation to occur. Now we should have the same movement as the other leg. You can select the armature, go to the post view, and activate this X here on the right top corner. By doing this, if you move one side, you can check if the movement is similar to the other side. So far it's looking good. I think we are in the right way. And if you put your armature in a pose that you don't want anymore, you can go here in pose, clear, transform, and all. This will reset the bones into their default location. Now for the back leg, I'm doing this way. I will copy all the bones from one side. I'm copying the left side, and I will Shift D and right click to confirm it. So I have this copy here, and I'm going to press S, Y, -1 and confirm it. And now move it to the correct position. It doesn't need to be perfect, but the better you get at the center of the rotation, it will look better. Oh, since I had the symmetry, it copied all the bones to the other leg as well. And now we are going to rename the bones so it doesn't get messy. So select all the back bones, Control F2 to bring up the battery name. Make sure it's on selected here instead of objects on bones. And now we are going to find and replace. We are going to replace front with back. And boom. Now the back legs are named correctly. Let's see if the IK is working correctly. And now, since after I duplicated, I changed the scale in the y-axis by -1, I have to change the lock rotation on this bone here. Instead of locking the X, I'm going to lock the Z. And do the same for the other side. And now I'm going to repeat the same process as we did before of parenting the meshes to the bones. Now I'm going to hide the bone names again by going to Data, into Viewport Display, and disable Show Names. So we have a better view right now. And if we go into posing mode, activates the symmetry, we can see that if we move our robot right now, we will have some kind of believable leg movement. If we select the root bone and move it, our legs will move accordingly. And now we are ready to start animating our little robot. Before we start animating, I will make sure that the settings for the animation and the export are correctly set. I will go into the output properties. Under output properties, go into output and select where you want to output the file. As an example, I made an animation folder on my desktop. On the file format, you have many options. First, there is PNG, which will bake all the color measurements that you have in Blender. The second one is FFmpeg video, which will bake the color management options as well. But if Blender crashes during the rendering, your file may be corrupted. And there is the better option, which is OpenEXR. But this option doesn't bake Blender's colors, which we will have to apply in our editing software later. I will use DAVINCI Resolve. But the advantages of OpenEXR is that it has a way smaller file size and it's way faster to write up the data. So your renders will be faster to save than the PNG option, especially if you are using high compression. So the options for OpenEXR are RGB if you don't have transparency, and RGBA if you have some transparency. For color depth, you probably can use half, and for the codec, use DWAA lossy. I will use Eevee for this animation, but you can use cycles as well. With that done, I'm going to add a camera by pressing Shift A and going into Camera and a new camera. I will select the camera, I will go into the camera view and click on this little padlock to lock the camera to our view. Then you can frame the animation the way you like and untoggle this option here. Since the robot is more vertical than horizontal, I think this 16:9 looks kind of odd, so I will change it for a square resolution. and I will adjust the camera view. In the output properties, you can change the frame rate to whichever frame rate you want. I will go with 30 FPS here, and I will change the number of frames here. I want 300 frames. Select our camera. First, I'm gonna put it just a little behind. Now I'm gonna press I to keyframe it. And now I'm going to press Shift and right arrow to go to the last frame. Press G and ZZ to move the camera along its Z-axis so it moves closer to the robot. I think that will do. It's just a slight subtle movement. And press Y again. So let's see our camera movement. You can see that it starts slowly and then it gains speed as we approach the middle. That's because our speed is not linear. For that, so I'm going to select the camera, press A, and press right mouse button and go into interpolation mode and set it to linear. Now the speed of the camera is constant. For us to better view the animation, I will grab here and put another window where I will left it on the camera view. And for better viewing, I will turn off the overlay for the viewport. Now I'm going to add a plane, and we are going to start animating the robot. I think I'm going to make an animation as if he were sleeping. So I'm going to put him down like so, as I imagine he's sleeping, and press Y to set up the keyframe. Now, if you press play, we can see that the robot is in the position that we set it up. I think that I will change the camera angle. I will put it in a 3/4 view, I think, like so. Press Y again, and then go to the last frame and do the same. So now you have a better view of our model. I forgot to tell you that you need to be in the pose mode in order to pose your armature, not in the edit mode. So you can change which bone you are using. Now in the first frame as well, I will start to move the legs to the position where I want them. It's just a slight adjustment, nothing too crazy. And I will select them and press Y. You can see that I was moving the legs with the IK controller, but you can move it in with the individual bones as well, and to respect the constraints. Now I'm going to start animating the main body movement, so it wobbles up and down like he was breathing. I can copy the first frame and paste it over here. Now I can copy these frames and Shift D to duplicate them. By pressing spacebar, you can see how our animation plays out. Now I'm going to set up a simple light and simple materials so we can have an example render to throw it on DaVinci Resolve later. I'm going to press Shift 8, go into light, and I will select an area light. I will position the light roughly at 45 degrees with the camera in relationship with the robot. So like so, rotate it towards the robot. And now I'm going to increase the power of the light. This is too much, I think. For me, 40 watts here, I think does the job. I'm going to increase the size of the plane, set it to scale, and in the far side, I will extrude this and bevel these corners, just like so. Set the smooth to shade smooth or auto smooth. I will add non-reflective material to the plane. So let's see, background. I will choose a darker base color here, and the roughness to 0. Oh, sorry, the roughness to 1, and I will reduce the specular as well. Now I'm going to create some simple materials for the robot. I think that in my other project, I made him to have a plasticky kind of look. So I will do the same here. So I will add a new material, name it red plastic, change the color, a very saturated red I think looks cool, and change its value to a darker one. Since red are normally darker in nature, the roughness I will turn it down a bit so it's more reflective, and it looks like it's a very smooth and hard plastic. Now I will select all the parts that I want to be red. Now that I have some parts that I wish to be red as well, I will select the lid here, press Ctrl L and press M to link the materials. Here you can have fun and do as many materials as you like. Now here I want a darker material that would probably be something like a coated carbon fiber. And now that we have set up our materials, lights, render output settings, and scene, we can go into wireframe mode so you can save a little bit of resources, and then go into render, press the render animation. Now you can see the animation has finished rendering. We are here in the frame 300. And now I'm going to show you something. Remember that earlier I told you that since we will export in OpenEXR, our colors would look different than what we see in Blender. That's because OpenEXR doesn't bake the color management look that you have in Blender onto the file. So you can see here on the right, the OpenEXR is very different from the colors that we have in our Blender scene. So to fix that, we are going to jump into DaVinci Resolve. So now in DaVinci Resolve, I'm going into the Edit tab. And now in the folder that we exported our footage, I will select all the frames and drag them into DaVinci. You can see that DaVinci Resolve recognizes that this is an image sequence and import them as a video. First, we are going to right-click our sequence and go into Clip Attributes. And I will change the frame rate from 24 to the frame rate that we had in Blender, which is 30 FPS. I will create a new timeline. I will change the resolution and the frame rate and recreate. Now I'm going to drag our footage here, and you can see that the colors are still not we can see in Blender. Now we are going into the Fusion tab, and here I'm going to press Shift Space and type OCIO and select OCIO color space. Here on the right corner, we will point to our Blender config file for colors. So go into Browse. My Blender is on my C drive, Program Files, Blender Foundation, your Blender version. Go again into Blender, your Blender version, Data Files, Color Management, and config.ocio. Our search space is LinearRec 709, which is the same as we were using in Blender. If you're using a different one, you will need to select that. And the output space is the one that we want to have. So I will go for Chronos PBR neutral and use medium high contrast, since that is what I had in Blender. And we're done. Just need to export our file. And now on the left, I have the exported version from DaVinci Resolve, and we can see that we have a more cinematic view on the left one. And that's all for me for today. I hope that you were able to create a fantastic animation together with me, and as well how to have a file that you can share in the social media and put on your portfolio. Thanks and bye-bye.